Okay, so the number e, just like we developed pi, that's how we developed e. Zach? I know. The problem's still occurring. What is that? Hey, there we go. Problem solved. Okay, this is how we develop the number e. Okay, 2 is an irrational number. And there's the approximation for e. Okay. For some odd reason, this is special. Just like pi is special. Not quite as consequential in your math studies as pi. It would be if you kept going, but it has a lot to do with exponentials. Okay. It follows the same general shape. So if you want to graph this exactly, if you use the table of values, what's e to the -2? 1 over e squared, which is 1 over 2.718 squared, right? Because that's e, right? If you have a calculator, there's actually an e on it. It's a blue above the division sign. You have to hit second, divide. On these, if you hit second and the division key, it'll pop an e in there for you. You don't even have to write 2.71828. Okay. So what do you get? What's e to the -2?
I got 0.135.
I got 7.38.
Okay, that's e squared. No, it's not. Recalculate, Zach. E to the -1. Okay, what's e to the -1?
Oh my god. 0.367.
Okay, e to the 0. Quickly. No calculator. 1, thank you. E to the 1?
2.1.
Yeah, that's e. And e squared.
7.1.
You're up, Zach.
7.89.
Okay, so you can see this starts to grow exponentially. Okay. Get used to calculating with e, because you're going to be able to use. You're going to use it. We can put exponential growth and decay in terms of E. Instead of the formula I showed you last week. Here it is in terms of E. That's what we used last week, right? Those are this. Okay, those can be used interchangeably. The question is, do you know what K is? Because T is still time. Start amount. K is some constant. Okay, it's a number. We don't know what it is, it changes. It's kind of like the rate. Okay. Start amount, AMT. Yeah. K is a constant. E is a number. You know. Yep. Good question. It can change.
Oh, I think that is.
I sense your sarcasm.
Yeah, that's pretty obvious.
Yep. All right. So, how do we use it?
Plug numbers in, there we go.
Pretty much.
Plug and chug.
Yep, it is. It's plug and chug. There's an application in your book. Okay. Using this. Do you guys know what DDT is?
No.
You probably don't because it's really bad. It's a really effective pesticide that was used in the past, but it's also very effective at hurting people. It was used in mass quantities. People got sick because of it, so it's actually banned for use in the US. Now they can still use it in other countries, which is bad when we import food from Mexico. They can still use it, I think. Anyways, so it was banned.
I don't think Clemson would.
They probably wouldn't. Yeah. So that's why I say maybe. I don't know. Yeah. So let's see. In 1973, there are 1 times 10 to the 9th kilograms of DDT in the environment. It does decay for a value of K, negative 0.0211. Okay, how much? Yeah, I just did. Yes. Okay, how much remains in 2005? Oh, write the equation. What do you got? What's N0? Yeah, it's our start amount, so we need that right there. What is, okay, we know what E is, right? We know what K is. Right there. And what's the time frame? Can you do that math? Wrong answer. I know you can.
That's a big number.
Yep,
Why?
I do. It might be.
196442582.
Number one.
Say it again.
196442582.
Check your calculations, Zach.
I got 6.47.
I got that.
And I'll take it at 1.8.
Because that's bigger than the original amount, Zach. 50905. I'm pretty sure that's the right amount. So you need to work on your calculator. Okay, what's 1 times 10 to the 9? 1 with 9 zeros behind it? I believe so. This was your calculator. Oh, these, I was just counting. Yeah, those, this is going on the table. Zach, I could tell you your answer was wrong because yours was bigger than the original number. That's what it should look like. Okay. Any questions on that one? The other formula you're going to use is interest. You remember I showed you an interest formula last week for bank accounts? Let me see. What is it? Okay, that was last week's formula. You can compound the interest any number of times a year. We can also do what's called continuously compounded interest. Okay, that involves using E. If you have a bank account and it says continuously compounded, that's the best way to earn interest. It's continuously accruing. Versus compound interest where it only accrues once a month, or once a year, or once every 6 months. So 2 different equations, using them for the same purpose with just 2 different scenarios behind it. Okay. Again, P is principal, R is rate, T is time. Okay. I'm going to leave it there because it's another plug and chug. Okay. Any questions? You guys sufficiently confused? The number E is just like pi. So just use the decimal approximation or the key on your calculator. That's all you really need to understand. Okay. Yeah, it's tomorrow. There you go.
I'm giving you an option there to pick a question 8 through 16. Pick one of them, yep. I did that because there's the psychology, physics, civil engineering, banking, sociology, customer service, and marketing. So if any one of those are somewhere that you might think you're going, I'd encourage you to try that one. Okay.
Where are you gonna start doing pre-cabin that stuff?
That's the next chapter. We probably won't start that until after spring break. So I wouldn't worry about it right now. I'll let you know. All right. We'll take a look at that tomorrow.